How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some molecular orbitals practice problems. So problem number 1, the bond order of any molecule containing equal numbers of bonding and anti-bonding electrons is 0. All right, so bond order is equal to 1/2 the bonding electrons minus the anti-bonding electrons. So if you have the same number of bonding electrons and anti-bonding electrons, when you do that math, you get 0, and 1/2 of 0 is still 0. Or number 2, which options, could be multiple, correctly fills in the blank for the following statement? In comparing the same two atoms bonded together, the blank, the bond order, the blank, the bond length, and the blank, the bond energy. So let's check. Let's see. Two atoms bonded together, the smaller the bond order, the greater the bond length, which is true, and the greater the bond energy. Nope, sorry, that last greater makes it wrong. B, the greater the bond order, the longer the bond length. That's true, and the greater the bond energy. Nope, sorry, incorrect. C, two atoms bond together, the greater the bond order, the greater the bond length, and the greater, nope, the bond energy. So not true. All right, two atoms bond together, the smaller the bond order, the longer the bond length, true, and the smaller the bond energy. That is a true statement. What about the greater the bond order, the shorter, yes, the bond length, and the greater the bond energy? Yes, that's true. Choice D or E. Number 3, circle the options in parentheses that correctly complete the statement. In molecular orbital theory, the sigma 1s orbital is filled, empty, or half filled, and the sigma 1s antibonding orbital is what in an H2 molecule? So H2, well, each hydrogen has one valence electron. So when we do the molecular orbitals, we take these atomic orbitals, we mix them together, we get a bonding orbital and an anti-bonding orbital. So now we got to put those electrons into these bonding and anti-bonding molecular orbitals. So 2 electrons, I go 1, 2. All right, well, let's see. The sigma 1s orbital is filled, and the sigma 1s anti-bonding orbital is empty in an H2 molecule. All right. 4. What are the bond orders according to molecular orbital theory for the hydrogen-hydrogen bonds in H2, H2 plus, and H2 minus? So remember, the bond order is going to be equal to 1/2 the bonding electrons minus the anti-bonding electrons. So if we have H2, again, we just have 2 valence electrons total. So when we put them into our molecular orbitals, they both go there. Up, spin down. Bond order for H2 is, let's see, 1/2 of 2 bonding electrons minus no anti-bonding electrons gives us 1. So H2, the bond order is 1. If it's H2 plus, that's saying, hey, we actually have 1 less electron than we do in the H2 molecule. So let's see how this math checks out. We have 1 bonding electron, no anti-bonding electron. So half of that will give us a bond order of 0.5. So H2 plus has a bond order of 1/2 or 0.5. And H2 minus tells me, well, hey, we had 2 electrons, and this minus means we have 1 more electron. So we have 3 electrons total. 1, 2, 3. Bond order for H2 minus. Well, let's see. It's going to be 2 bonding electrons minus 1 anti-bonding electron, and 1/2 of that gives us a bond order of 1/2 as well. All right, and that's it. Hope you found it helpful. See you in class. Okay, bye.